Hello, my friends. It's my great privilege, honor, and pleasure, delight to speak again on You Are the Universe. You Are the Universe, discovering your cosmic self and why it matters. A book that we co wrote, Menas Kafatos and myself. And I thought of actually doing this interview after I watched this film that's out right now, Oppenheimer. And I remembered that actually Menas was a student of Philip Morris, right?
Philip
And,
Morrison.
and Philip Morrison, who in turn was a student of Oppenheimer. So the movie I saw was very well done. Have you seen it, Menas?
I have seen it's very, very good.
It's very good. The acting
Yeah,
is amazing. It's interesting to me that and I can see why, because it doesn't have direct application to, what you and I are interested in, other than the fact that there's one scene, pretty sexual scene where the Bhagavad Gita shows up, where, I am death, I am time, quoted from the Bhagavad Gita. And I did read then about Oppenheimer, and I realized he was a student of the Vedas, and
yes,
actually very much so. So I was kind of looking forward to any mention of David Bohm and any mention of, Schrodinger and all these amazing guys who were the pioneers, and there was very little of that. Niels Bohr and all that, very little. But you and I have been interested in consciousness, and as we know, the pioneers were very interested in consciousness, but none of that actually comes up. Nevertheless, it's a great movie because what you realize is that these guys are brilliant. I mean, Oppenheimer and Einstein and all of them and that whole gang, but they were also troubled. As I read through Einstein's biography, all his emotional and sexual issues, which was the same with, to some extent with Max Planck, the
right.
same, of course, Oppenheimer. And it's very interesting that you can be so highly intellectually developed and still have emotional and spiritual issues, which these guys had. So, any comments on in any insights you got from Philip Morrison on this whole era of the atomic bomb?
Yes, thank you, Deepak. Morrison was very, very closely associated with the Manhattan Project, which was the project to build the atomic bomb. And he was quite young at the time. Um, and in fact, he assembled the atomic bomb. Um, he was one of the main people that assembled the atomic bomb that they dropped on Hiroshima. And afterwards, he went to see the city that was completely level, and he turned around completely. He sort of left working on nuclear and atomic physics. Of course, he was always a brilliant physicist, so he didn't really leave atomic and nuclear physics. But in terms of practice, he turned into astrophysics. So I met him at Cornell, and then sort of followed him up to MIT and became his student. He was quite trouble, and he actually fought, not literally, but as much as he could against the development of the hydrogen bomb with Edward Teller, who was pushing at the time, and pretty much following, of course, the path of his teacher Oppenheimer, who became very disillusioned. In any case, we did ask Morrison at the joint seminar between Harvard and MIT when I was a graduate student, if he were troubled by the bombing of Hiroshima and Nagasaki. He said, "Well, I will still do it." And we asked how come after all of this. He said, "Don't forget we were fighting Hitler at the time." So
And
they
they never bombed Hitler or
they
Germany,
never bombed
and the
Hitler.
war had come to an end, and Japanese
Exactly.
were
Exactly.
already ready to
Yeah,
surrender. So
exactly.
And with that, we spawned the nuclear age. You know, Pakistan, India, all these
Right.
countries have bombs. And, in
Nine
fact,
countries. 9 countries have them.
9 countries have bombs. And that all started with these guys. I mean, they could have been brilliant physicists and mathematicians, but only a troubled mind and a group of troubled minds and people are not connected to the source of experience, which we call infinite divine consciousness, could be responsible for this era that they launched.
Yeah. Morrison actually did quite a bit. He was writing science reviews for Scientific American, and he passed away fairly late age, and his wife Phyllis. So he was really a brilliant person and very nice person. When I met him, he was a very nice person. He had some really very bright eyes, and but he was certainly was trouble, and he tried to undo what had happened. But as you and I know, Deepak, that's the train has left the station. So
It's,
anyway,
it's the diabolical part of human mind. We are sacred, but we are also very profane at the same time. Both good and evil reside in us. So, anyway, that's a good recap of what happened. Do you have any other memories of that era? Because, I became very interested in David Bohm and his interactions with Krishnamurti. And as you know, David Bohm actually spoke of the implicate order and the explicate order. He also spoke about consciousness as fundamental. David Bohm also was targeted by the US government. I know that Einstein got him a job, I think, in Brazil because he was also thought to be a communist.
correct.
And David was probably the most spiritual of them all.
He was. Dave Baum was a genius, and of course, as you said, the implicate and explicate order, which is we can talk a little bit more about that in terms of complementarities. And indeed, Einstein helped him because he was being prosecuted and not really, not literally. They didn't take him to court, but they were very much against him. So he left the country and eventually went to back to England, and that's where he was and developed more his physics.
David Bohm tried to explain entanglement in a different way than, right now, if you read quantum mechanics, the whole talk is about superposition, entanglement, non-local correlation, synchronicity, and all that. And there's still confusion, because of Einstein's remark, spooky action at a distance. But, David gave this example of a fish in a tank, and you're looking only the head, and you're also can see the tail. You can't see the rest of the fish because of the way you're looking at the fish in the tank. And every time the head moves, the tail moves in the other direction simultaneously. So you think there's some spooky action at distance, but it's just the whole fish moving. And I think entanglement, spooky action at a distance are very misleading because entanglement actually is, in a way, I think it could be misunderstood because if you look at the whole picture in a holistic way, then it's one universe with several moving behaviors, not even parts, because parts are behaviors. Okay, when you say particle, you just take a snapshot of a moving wave and then you say that's a particle. But actually, there's only the waves of possibility, and the particles are snapshots. I would say snapshots of perceptual activity. They're space time events in consciousness. But we, because we observe them as separate entities, we think there is some spooky action at distance, but it's not. It's one organism moving. And I think even the word part is mistaken. In the holo movement, there's no part. The part is a movement of the whole, and it's a fragmentary movement. By the time you observe the particle, it doesn't exist.
it doesn't exist in that particular state, that because it has moved on or interacted. So actually, what you're bringing up a very good point, the whole issue of space-time. And I know that Bohm was quite interested in that, and that's actually part of this whole thing with the implicate order. So you have space-time, and maybe we can talk a little bit more about that, which presumably started with the Big Bang, although, as you have said before, it's a big mystery what was before the Big Bang. Does it even make sense to call before when there was no space and no time? And so in terms of physics, we have this dilemma, and you have spoken about it many times, the dilemma of what appears to be the outside world, the world out there. And then we come up with all kinds of explanation interpretations, which if you take them from the point of view of the world out there, which is really what science is trying to do, is to try to understand the world out there, then I guess it makes sense to build the edifice, the tower that way. But in fact, as you and I know, it doesn't really work in the end. And what happened was that the quantum revolution unseated the whole thing. And to this date, and I'm a little bit concerned because most scientists who are brilliant in terms of quantum physics and understand, I'm talking about physicists, quantum physicists, they don't go the extra mile. They don't go the extra step and say, well, what does this all imply? So I will leave it at that at this point. Yeah.
I'm in conversation with Menas Kafatos. He's the Fletcher Jones Endowed Professor of Computational Physics at Chapman University and the author of more than 320 refereed articles and more than 15 books. He's also the co author of You Are the Universe Discovering Your Cosmic Self. So, over the years, Menas, I've heard you talk about three principles, which I find very fascinating, and they are complementarity, creative interactivity, and the third one is
Universality.
universality. But there's a fourth one, I think complementarity, creative interactivity, and universality, that there's a good, and then entanglement fits in somewhere there, right?
The entanglement basically comes out of all of this. Yeah.
Okay. So let's talk about that for a moment because, we think of waves and particles as two separate things, but they're complementary to each other. You can't have one without the other. Say a little bit about complementarity because that's a very unique contribution, which actually Niels Bohr also spoke about, I think.
Absolutely. Niels Bohr, in fact, not only spoke, but he developed the concept. And he has been ignored, I have to say, or misunderstood by, again, a lot of the physicists because the reaction, usually the reaction, and I'm sure you you have experienced that yourself, Deepak. You said, "Oh well, what does that mean? I mean, you're not saying anything really profound here. You're just okay, complementarity." But actually, if you dig into it, then it's a very deep principle, and it is actually the principle on which quantum physics is based on. Niels Bohr understood that. In fact, the whole arguments between which went 35 years or more between Einstein and Bohr. They were very close friends, by the way, but they disagreed tremendously on what really the meaning of quantum physics was. And then others jumped in, like Werner Heisenberg, of course. Actually, Werner Heisenberg and Bohr were, founders of the quantum physics in the 1920s. So the point here is that Einstein, even though he actually got the Nobel Prize for it, for quantum phenomenon, which is called the photoelectric effect, he was troubled by the implications. And of course, he came up and said, well-known statement, do you think that the moon is not there when nobody is observing it? And it is a very difficult question. In fact, Einstein put his finger into it because you cannot answer that question. I don't think you can answer it from the point of view of an external universe. And so he was troubled by that. And Einstein and Bohr went on for quite a while. I don't think Einstein was convinced. And I think in the end, Bohr was perhaps vindicated in some ways.
So we're back. We had a issue with technology, but we're back. Continue where we left off.
Entanglement.
Entanglement. So you were talking about complementarity, and you were saying it's not an easy concept for people to understand that Einstein and Bohr argued about it all the time. By the way, I heard a joke a while ago, and that is that Niels Bohr is buried in Copenhagen, and Einstein's ashes, I believe, are buried in Princeton. And
Correct.
whenever Niels Bohr turns in his grave, Einstein turns the other way. And it happens instantly without any spooky action at a distance. So I think that's the best explanation of entanglement. They are entangled even though they disagree.
Correct.
But,
Correct.
but go ahead, you were explaining complementarity, wave particle, but I think every experience has an opposite, and the opposite is not an opposite, it's a complementarity.
Exactly. We did, I think, because of the tricks of the mind. Of course, we love the mind because without the mind, we would not be human beings. But because of the mind, as perhaps the ancient philosophers and the ancient teachings are telling us, is what creates this whole uh, apparition or appearance of the universe. And in fact, you did mention that. That Bohr and in fact Schrödinger, who also did not particularly like the way the Copenhagen interpretation was going, named Copenhagen because, of course, the Institute of Bohr was in Copenhagen, and it still is. So this idea of duality, which is a trickster mind is playing on us. And if we didn't have the duality, then we would not have the universe, right? And I think you talk about it very beautifully, Deepak, in one of your videos that we need some sort of rethinking or revolution in both science and religion. We need to perhaps start with the path that the founders of quantum mechanics showed us, not leaving Einstein out, because as I was saying just a little while ago, Einstein was also to a large extent correct. And this is the dilemma of the human mind, because we always think of in terms of yes or no, black or white, up or down. But in the complementarity, as we know, um, having it studied for many years, many people, many of us, Bohr was right. It's not just a simplify. It's not just a simplistic thing that somebody can laugh at and say, "Oh, well, you're not really Niels. You're not telling us anything new." But it is a very deep principle which gives rise to the universe. But
So
it is
let's say
difficult.
that principle says opposites are complementary to each other.
Exactly. So
Now,
opposites are not really opposites. They are, if you like, the two aspects of a wholeness. And if you take one out, the other one is not there either. So
okay, so that's principle number one. Now, uh, say a little bit about your views on the second principle, creative interactivity.
So uh, um, creative interactivity is actually pretty much the foundation of quantum field theory. If we look at it from that point of view, in the sense that there's a continuous dance, if I can call it, between uh, waves, because really in the end it is waves, which when they are observed by an observer or in an experiment in laboratory, the various probabilities collapse into something specific event, which can be recorded in photographic plate in the old days or, in computer. And then you say, oh, something happened, right? And there was the electron. But of course, you never really see the electron. What you're seeing is events in space-time. And then we interpret them and say, well, this is what happened in terms of an electron interacting. And quantum physics is so exceedingly beautiful and accurate that to the 16th decimal place, we can actually predict, or actually we can understand what's happening in the atomic realm or the molecular realm. And so this whole issue of interactivity is telling us that, first of all, it's creative because particles come and go. They come and go out of the vacuum of space. Also, as we have said many times, out of the Planck level, or maybe even beyond the Planck level, they come out and they interact with each other. And we record them and we take snapshots or whatever with our instruments. And so this is the creative part. Of course, whenever you have creation, you also have disappearance. So the particle comes and then it goes. So in the world of the quantum, nothing is permanent. What is permanent, I think, is the act of observation. So it sounds like I'm making a big jump here, but going down the proverbial stairway to the depths of understanding, if particles are not real in themselves, then what is left? And this is maybe what we can say more, but it is this creative interactivity that's very, very important.
As you were speaking, I was also thinking of Schrodinger, who's most known for his Schrodinger's cat paradox. But if you read his book, What is Life, towards the end, he actually goes on to quote the Vedanta, as consciousness being fundamental. You say he was troubled, but he was also, in a way, responsible for this equation which describes every atom in the universe, one simple equation, Schrodinger's wave function. And I think in the end, he was more on the side of Niels Bohr than on the side of Einstein. Would you agree?
Correct.
Yeah.
Because Schrödinger was also a realist. They were all, by the way, philosophers. They were friends of wisdom, as the ancient Greeks called it. Schrödinger, actually, the way we teach quantum physics today, we use, quite correctly, you pointed out, we use the Schrödinger equation. There's also the complementary. In fact, that was the beginning of the complementarity. The complementary way of describing a quantum set of particles or happenings, so to speak, and that is Heisenberg's approach. But it is much more, it uses matrices. I won't go into those details, but matrix mechanics is the same as Schrödinger mechanics, as wave mechanics, but it's much easier to visualize the Schrödinger waves than to visualize the matrices of Heisenberg. But they're totally equivalent. They are the most fundamental complementarity in quantum physics.
As I read some of the history, and by the way, I'm reading this very amazing book right now. I'll show it to you. It's called Too
To be,
Big for a Single Mind.
yeah,
And it's about the development of quantum mechanics.
right.
And it's really a very interesting book. But as I look into the history, it was Einstein who first described the Einstein-Podolsky-Rosen equation and actually gave the math for entanglement. And then he said, oh, it's spooky action at a distance, but he's the one who created the formula. He also described the cosmological constant, which now we call dark energy, where the measured value and the actual value are amazingly different. But he also called that the blunder of his life. And yet he was responsible for creating these concepts which you use right now, entanglement and dark energy and cosmological constant are Einstein's contributions.
Absolutely. Cosmological constant, actually, in my view, was not his greatest blunder, but maybe his greatest creation. It goes basically what John Archibald Wheeler was calling that the only physics that is worth, maybe it's an extremist statement, it's the physics of the vacuum. And the cosmological constant talks about the vacuum a lot.
Okay, last principle that you wanted to talk about, or I wanted you to talk about universality.
Correct, universality. So you cannot do science without universality. In fact, all three principles that we just talked about, they really if you look at them from a certain point of view, they're really just one principle. And that is the principle of that consciousness drives everything, if I can jump to the conclusion. But universality is, we believe that and it was Isaac Newton, I believe it was at least equal to Einstein in terms of really having founded the principles or the foundations of modern science.
Newton also spoke of those principles. Basically, when you talk about universality, I was trying to look up some of the current concepts, and maybe this has to do with universality. The universe is isotropic and homogeneous, and that means what is here is everywhere, and what is not here is not everywhere. And I went on one of these AI chatbots and said, does that imply right now, there are people are talking about 60 billion habitable planets, 2 trillion galaxies, on and on. But it must imply so here, so everywhere, that there are parallel life forms across the universe, just like you and me, if the universe is isotropic and homogeneous. What do you say to that?
Yeah, homogeneity and isotropy is a consequence of universality. Universality is a deeper principle. And again, going back to what I was saying a little while ago, without universality, you will not have science because it's very difficult to do science if you say, well, whatever applies here applies just here, but not on the moon or not on the sun. And in the same way, actually, universality is an accepted principle of religion, right? And so it is at least curious to me, and I know that you and I have chatted many times about this, how similar and how dissimilar science and religion are, in the sense that the fundamental principles which are based on philosophical ground, and we can say ancient Greek and ancient Indian, and maybe also ancient Chinese. These principles, this way of outlook, cuts across all cultures, all segments of time, all historical events. And yet, even though sort of it's staring us in the eye, so to speak, I don't know, this is a little bit of a metaphor, but maybe are we so blinded by our own sense of ego?
Yes. Okay. Well, there's a lot to discuss, and we won't be able to go through the book. But I will read the chapters in the end of the book, but I want our audience to understand this is a little bit of an update from the book because of the current conundrums that are being addressed. And the conundrums exist because you mentioned earlier that we believe in realism, or our science is based on what is called naive realism. And naive realism has the following four problems that I have been thinking about. Number one, matter is the ontological primitive of the universe, when in fact nobody has observed a substance called matter. We can only observe our perceptual activities, and then we create the model that we call matter. So number one. Number two, naive realism is based on subject object split. I'm the observer and that is the observed, when in reality observer and observed are movements of one wholeness. Number three, that the picture of the world is the exact human look of it. And number four, you need an observer, that the universe is observer independent. None of these assumptions seems to be true. Those are problems with current science, and also the problems that we don't know what happened before the Big Bang, we don't know what happened in the Planck epoch, why the cosmic inflation is so precise for mind, life, and the universe and our own consciousness. A lot of problems, and so I think our book addresses all these. And I just want to read the chapter headings. Part one is the ultimate mysteries. What came before the Big Bang? Why does the universe fit together so perfectly? Where did time come from? What is the universe made of? Is there design in the universe? Is the quantum world linked to everyday life? Do we live in a conscious universe? how did life first begin? Does the brain create the mind? By the way, that's a complementarity. Brain and mind are complementarity activities in consciousness.
Correct.
Then the rest of the book is embracing your cosmic self, the power of personal reality, where you really came from, etc., etc. So I would encourage people to look at this book once again because it's very timely now to understand that without consciousness we can't do science, as Menas said. Even if we talk about multiple universes or infinite universes, those are concepts that occur in the human mind, so you can't get rid of the human mind and the fact that the mind is a modified form of consciousness. So ultimately, consciousness conceives, governs, constructs, and becomes that which we call the universe, and we are entangled. The biological organism is entangled with the appearance of the universe that corresponds to it. Would you agree that there is, in a way, no universe? The universe is consciousness, but appears differently to different species.
Yeah, actually, in a way, there's no universe. And if Wheeler was right that all the physics is really in the vacuum, then until we understand the vacuum, we don't really understand science. I deeply believe that. And of course, this is where actually Einstein and quantum, and Bohr and, the general relativity and quantum physics come together. What I believe that in our dialogue with Deepak, what we're bringing to the picture is actually the role of the mind itself. And it's not a foreign idea, because the early quantum physicists, in fact, particularly Wolfgang Pauli and Heisenberg and Bohr, the three main pillars of the Copenhagen interpretation, and then later on John von Neumann, they knew and they appreciated the role of the mind. And in a curious way, also Einstein and Schrödinger on the other side, because Einstein famously said that it's all creations of the mind. the same Einstein who was troubled by what quantum, the EPR experiment, the Einstein-Podolsky-Rosen experiment, would imply, that there is connectivity across all scales, and that actually the idea of external reality is probably not quite correct. Yeah.
One last thing that I want to get your opinion on, and then we will close the session with a few concluding remarks. We talk about observer independent universe, which is impossible to prove. But the question is, in all my readings of scientific literature, observer is anything that records. It could be an instrument, it could be a biological organism, it could be, the mathematics involved in it. And then you have this Eugene Wigner's essay on the unreasonable effectiveness of mathematics. All these problems are easily addressed if we understand mathematics is an activity in consciousness, that human consciousness is entangled with cosmic consciousness, that there are lots of conundrums right now. And all these conundrums can be solved if we take consciousness as fundamental reality, without which we can't do science. And all these people, including Einstein, when he's imagining himself in a beam of light or whatever, the assumption always is that there's an observer in the body, but the body itself is an observation, the mind itself. In the Vedanta, mind, intellect, body, the five senses, these are objects of observation. The observer is non-local and not to be found in space-time. Would you agree with that?
I totally agree. And I would say that besides the whole issue of vacuum physics, which gets quite esoteric, the biggest conundrum we have, I believe, is the whole role of the mind. Okay, what is how can the universe exist as an external entity if our mind is so entangled with it? So what happens often is scientists, as well as philosophers, and I'll be speaking about scientists, as I'm a scientist myself, they sort of a dance around the issue. And yeah, sometimes in a cute way, sometimes in demeaning way, as we know, Deepak, you and I. and some of our friends, demeaning away and say, well, what is this a thing of the observer? Well, without the observer, there would be no theory of relativity. The theory of relativity is based on frames of reference moving with respect to each other. So there is the observers imply, and so the same thing, of course, to very, very large extent with quantum physics. So the observers imply, it doesn't mean that it doesn't exist. Okay.
Okay, so last thing, and I want, you said I've been ridiculed, vilified, all that, and that's fine because I'm not a
That's
physicist.
fine.
You're a physicist and you're a quantum physicist.
Right.
I want to ask you 5 questions and then we'll conclude. Number
Okay.
one, when we talk about quantum consciousness, let's look at why we talk about quantum consciousness. Before you have a thought, it's in superposition with every other thought. Yes or no?
Yes.
Number two, the appearance of a thought is determined by the uncertainty principle because we don't know what our next thought is going to be.
To a large extent, yes, but it goes even beyond the uncertainty principle. Yes, I would say in terms of quantum physics, yes.
Okay. Number three, before you observe anything, it exists as a possibility. The observer itself is infinite possibilities.
Yes.
And number four, the observer localizes itself through attention and intention. Ultimately, that's what creates an observed particle. You design the experiment and then you determine what is the outcome.
You determine, or at least you determine the theory that will give you the answers. Yes. The
Okay.
answer is yes.
All these things suggest that quantum mechanics and quantum consciousness go together.
You could not have quantum mechanics without the mind, and we call it quantum consciousness, but other people call it the mind. You could not have one without the other.
So I have been speaking to Menas Kafatos, and we have mentioned the solutions to the current cosmological conundrums and even the current quantum mechanical conundrums. One of the biggest conundrums right now is quantum mechanics and gravity. They don't fit. And I think the answer to that from Vedanta is they are actually complementarities because they're different modes of observation in the same consciousness. So if there are different modes of observation, one is a mode that is looking at the micro world, one is a mode looking at the macro world, and therefore there's no conflict between quantum mechanics and gravity. They're just equations derived from different modes of knowing. Would you agree?
I would agree with the big addition, and of course, again, you and I agree on that, that you cannot combine, it would be a mission impossible to combine general relativity and quantum mechanics without the role of observation, without the role of the mind. This is why consciousness is the underlying reality.
This has been very fruitful. Menas, I thank you very much.
Thank you.